We'll be looking at a lot of different qualities of light this semester. In terms of photosynthesis, though, it's important to pay attention to intensity as well. So we measure intensity in foot candles, which is kind of like horsepower. We're not pulling cars by horses, but similarly, a foot candle is traditionally the amount of light that one candle would illuminate a square foot of surface area about a foot apart away from the candle, the light source. So we're not lighting our greenhouses with candles, but we still use that term. So in terms of plant growth, if we think about photosynthesis as a process similar to eating food, we are not autotrophs, so we have to eat food. And if I am using more energy than I'm eating, I'm going to starve to death. And plants are similar in terms of photosynthesis being the process by which they create food, they create energy or fuel, and then respiration, which is the rate at which they use it. And so when we're talking about plant growth, we have to think about those two processes in balance. If I'm respiring, if I'm using up energy at a greater rate than I am producing it, as a plant, I'm not going to grow. Right at that point where those two are in balance, right, I have just enough to carry out the functions, so the rate of photosynthesis is equal to the rate of respiration, we call that the compensation point. And that's a point at which any more additional rates of photosynthesis, an increase in rate, would lead to growth. And so that's what we see here. There's other limiting factors when it comes to photosynthesis that we'll talk about, such as CO2 levels, water. And so light is not the only limiting agent. You can have all the light you want, but if you run out of water or you run out of the CO2, you're not going to be able to increase your rate of photosynthesis. So that's something to keep in mind. Because we also have in plants what's called a light saturation point. When plants, if I'm a grower and I'm growing in the greenhouse, it's wintertime, I might want to use additional artificial lights. And certain plants, the rate of photosynthesis, it's going to increase, and therefore the rate of growth can increase up to a certain point. In general, most plants around, kind of the range of 1,000 to 2,000 foot candles have what we call a light saturation point, where any additional amount of light is not going to lead to additional rates of photosynthesis, because your plant, depending on where it's acclimatized to, is going to know, hey, I'm going to run out of water or CO2 if I keep, or enzymes, if I keep responding to light at this higher rate. Plants that are acclimated to shade, for example, might hit their light saturation point at much lower light intensities. So here they stop, so up till here's the point of compensation. Here they're growing. Right here is their light saturation point, and any additional increase in the amount of light intensity, they kind of top out. They kind of stay even here. And at some point, if we follow this graph out way over here, just like we get sunburn, plant tissue damage can occur. In a plant that has much higher light saturation levels, we continue to see, past this point, an increase in the rate of photosynthesis, but eventually, right about here, we see that light saturation point. And again, further out, as we continue to increase light intensity, we may see the death or senescence of the tissue. And so more light can increase the rate of photosynthesis, which could equal growth, but you have to keep in mind, again, the balance between photosynthesis and respiration at that compensation point, and then the saturation point at which no amount of additional light, and therefore paying for electricity or artificial lighting beyond a certain point is not any more beneficial. Now keep in mind, we're talking about intensity, so the how bright a light is, and not necessarily the time, which might influence other factors that we'll talk about later, such as different stages of plant growth.